I want to talk about mortgages or loans. A mortgage is just a loan that the bank is giving you. Okay, so the idea is that the bank are going to give you a loan. We're going to call the loan P. That could be a mortgage to buy your house. So that's the loan that the bank are giving you. And you want to pay back that loan with regular equal payments of A over N time frames. So N is the number of payments you're going to make over N time frames. And you need to work out what is that A that would be the equivalent, all of those A's would be the equivalent of P at the current present time. Because you see, obviously if money is present now, if that money gets put into a bank, it earns interest. So it could earn interest at a rate of I per I. We call it I as a decimal. Okay, so that's the interest as a decimal that money could be earning. Okay, so obviously if the bank are giving you P now, they could have had that P somewhere earning interest. So there's no point in you paying them P back in 10 years because their P will be worth a lot more in 10 years if they put it into a bank. Okay, so it has to be a fairer system. So what you need to do is you need to work out your payments. What are their present values? So if you pay A in one time frame's time, okay, what was that? What would the value of that A be if you had it now? Okay, and we already worked out a formula for present value. So if you think about it, A divided by 1 plus I, which is as a decimal, the interest rate as a decimal, is the present value of that A in one time frame. Because if you put that much in now, then over one time frame you would earn the interest of you'd earn the interest of I, and the way you would work out what you would have after one time frame is you would take what you have now and multiply it by 1 plus I, which you can see then would give you your A. So this is the present value of your payment one time frame later. The 2 time frames later, when you pay that A, its present value right now is not A. Its present value is A over 1 plus I as a decimal squared. So that over 2 time frames, what's worth this now will be worth that times the 1 plus I squared. Okay, so again, the present value of that is this. Working all the way down, the present value of your final payment is A over 1 plus the interest rate as a decimal to the power of N, because we are saying there are N payments. N time frames, N payments. So for it to be fair, then the sum of all of these present values of your future payments should be equal to the sum of the money that the bank will give you. That's just for the bank to break even. Obviously, in real life, the bank will charge you more. Okay, but this would be just for these to be equal. These are the values of A the value of A that you require so that when you make N payments of them over a regular time frame, you will be giving the bank effectively back what it gave you at the start. So this is just a geometric series, and all we do now is we equate the geometric series, the sum of the geometric series, with the P that the bank give you, and we will then figure out what value would A have to be so that you are paying the bank back their P. Okay, so we're going to eventually look for A. So a geometric series, let's just work that out. What's the first term of geometric series is A over 1 plus I. Okay, the multiplier in this case is 1 over 1 plus I. As you can see, as you go from term to term, It's 1 over 1 plus I. And the P, the total that we want this to be, is the Sn, which is A times 1 minus R to the power of n over 1 minus R, remember? Okay, so let's have a look at what that needs to be. Rub it out, we'll start over here. So again, we want our P, the bank's loan, to be equal to the Sn of this geometric series. So it's equal to A, which is A over 1 plus I times 1 minus R to the power of n over 1 minus R. Okay, that's the formula that we want. Okay. Now we need to get A on its own. So we start by, first of all, just multiplying the top and the bottom of this fraction by 1 plus I as a decimal. Okay, so we're going to multiply the top by 1 plus I as a decimal, and we're going to multiply the bottom by 1 plus I. You don't normally see the D at the bottom, I'm just putting it in to remind you it's the interest rate as a decimal. Now, remember, when you multiply numbers together, you've got this number by this number by this number. So I'm going to multiply this number by this number and then multiply it by this. So we'll leave this bit alone just now. So that's going to be 1 minus 1 over 1 plus I to the power of n. That's this piece. And then multiply that by that and give it to your... so 1 plus I times A over 1 plus I will just give us A. Over, now 1 plus I times 1 is 1 plus I. And 1 plus I times minus 1 over 1 plus I is just minus 1. Okay? Now, it should be obvious here that 1 plus I minus 1 means that the 1 and the minus 1 will add to 0. The next thing we're going to do is we're going to note that 1 over 1, well actually 1 over w to the power of n, we've spoken about this before, is 1 to the power of n over w to the power of n, which is 1 over w to the power of n. Okay, so in this situation, 1 over 1 plus I to the power of n is just 1 over 1 plus I to the power of n, like that. Okay? So that means I can equate, so P is equal to A times 1 minus 1 over 1 plus I to the power of n over ID. And what we do now is we get rid of that fraction from the top, so we have to multiply both the top and the bottom of this fraction by 1 plus I to the power of n. So we're effectively multiplying it by 1, we're not changing it. 1 plus I to the power of n times 1, we've got our A still there. That times that is 1 plus I to the power of A, or sorry, 1 plus ID to the power of n. So that's that times that, and that times minus 1 over itself just gives you minus 1. And on the bottom, that times that just gives you ID times 1, or I as a decimal times 1 plus I as a decimal to the power of n. And that's equal to P. Okay, now let's move from that up here. So all we're going to do now is we want A on its own. So we're going to multiply across by the fractions. So P times ID times 1 plus I to the power of n, just multiply both sides by that, is equal to A times 1 plus I to the power of n minus 1, and then divide by this bit here to get a on its own. So a is equal to p times the interest rate as a decimal times 1 plus the interest rate as a decimal to the power of n over 1 plus I to the power of n minus 1. And that's the formula that is in your log tables. So again, just to be aware, you need to know the number of time frames you want to pay the money back over. You need to know the interest rate, the current interest rate for saving money. You need to know the amount of money that you're borrowing, and then you put it into this formula, and that will give you the amount, the value of every payment that you need to make. That thing that your payments value, and you're going to make them over n time frames. Okay, so that's your monthly repayment, or your weekly repayment, or your yearly, whatever way you want to pay the whatever time frame you want to pay the loan back over. Okay, then we'll do a couple of questions next, I think.